Yeah, hello everyone. Welcome to the session 8 of the Tech Roxx Electra Cohort. Okay, in this session, we're going to discuss about the hardware description language and the programming and the concepts of the digital design. Okay, here you can learn the Verilog, SystemVerilog, simulation of it, and RTL design. Okay, just go if you are new to here, just go through the previous modules which we have already delivered. Okay, before itself. Okay, and whoever in the live just have a thumbs up there. Just drop a thumbs up in the comment box, and let's start with the session. Okay, now as we have the traditional programming languages as C, C++, or Python, whatever. Okay, these are actually uh, they won't communicate with the hardware directly. Okay, this HDL or the assembler languages which are written in the hardware level. Okay, these are designed in order to define the hardware. Just we will learn all this very soon. Okay. Now there is a question like why we should learn HDL or the hardware description. Okay. It is actually used to design the critical software hardware systems across like if you need to create the C architecture and FPGA systems and any custom silicon chips. Or else there are some other things to do with this are we need to communicate the interfaces, right? So we need to learn HDL, and we have embedded hardware which will be using the HDL to design the hardware, like using the FPGA or something. And also we can build the AI accelerators and neural processors. You will soon learn about them also. And now we control the okay. You can see the code that hardware HDL is the language used to design real electronic hardware, not just software programs. Okay, it is designed to it is used to design the real electronics hardware, not like just a software program which will be running on your local host. Okay, these are built. Okay, these are used whatever we have like the chips, the microprocessors, controllers, and let's move on to the another slide. Okay, now we gonna see what is log HDL. Let's have it the Verilog. Okay, Verilog. It is a Verilog is a software description primarily used for building complex digital circuits and designing precise RTL systems, writing complex architectures, and we have writing the sequential logic architecture. Okay, we can also simulate hardware behavior prior to the fabrication. Okay, with this we can simply see the hardware behavior. Okay, now applications of VHDL goes on to the FPGA programming gate, which are the which have the combinational logic blocks, and we can simply manipulate the FPGA, this programming language, which is VHDL. Okay, and also in the ASIC design, which is application specific, and these ICs are made to reduce the power consumption and cost cutting. Okay, in this, like there will be a logic, it will be written for the specific application itself, like for a refrigerator we have, or for an EV, or for any other applications like the machines. Okay, and it is used in the digital verification. Okay, and for the processor, okay, you have the i3, i5, Snapdragon, whatever it is. Okay, these are designed using VHDL. Okay. In this, you just ignore these weeks. Okay. In this session, you're gonna see what about the Verilog basics, the modules, the ports and data types. Okay. Next, you will be learning combinational logic assigned statements. Okay. Always blocks, etc. And you will learn the sequential logic for the flip-flops, counters, and FSM concepts. And you will learn about the test benches, simulation, project, and debug. Okay, just give a thumbs up if you are getting something. Okay, these are all basics. Okay, you need not to worry like you are from the first year or second year or third year or a past year. Okay, just you need to make sure that you are listening to me itself in the meeting. Okay, we can go through this very soon. Okay, whenever you join an MNC or somewhere. Okay, if you got an job at an MNC or somewhere, you need to learn these things. Okay, now let's understand the modules in the HDL. Okay, a module. Just we can see it as a basic fundamental block of Verilog designs, allowing for hierarchical and reusable design structures. Okay, you can say it as the building blocks. Okay, you can see an example. Okay, you can see here these are the blocks. Okay, even these blocks are used to build something. Okay, e block okay, like for a toy or something or any project kit మీరు దాన్ని assemble చేస్తారు. In the similar way, modules are the fundamental blocks, okay, of Verilog designs, allowing for hierarchical అంటే ఒక ఫ్లోలో డిజైన్ చేయడానికి తర్వాత ఒక రీయూజబుల్ డిజైన్ ని స్ట్రక్చరైజ్ చేసుకోవడానికి వీఆర్ యూజింగ్ మాడ్యూల్. ఓకే, like we have input outputs, define the interface, and module declarations encapsulate logic. Now we have the internal signals connect the subcomponents. Now you can see our basic program, which is module adder. Okay, this is an adder module where we will be taking an input A. We are defining uh, A as an input, B as an input, and sum as output. Okay, and you will be closing the bracket and giving the semicolon. And now you have to assign the logic is assign sum is equal to A plus B. You can see somewhere. Okay, now you will be giving an array of A, B, C. Is it like that? Is it the same? Like input A, input B, and output C. Okay, and you are using the assign keyword, and you will be writing it as C is equal to A plus B. Now you will be the you will be ending the module using like this. Okay, like you have the return zero or something to terminate in the C language, right? So like that. మీకు సి లాంగ్వేజ్ లో ఉన్నట్టు కొద్దిగా అలానే ఉంటది. బట్ దిస్ ఇస్ కంప్లీట్లీ డిఫరెంట్ అండ్ ఇట్ హ్యాస్ n number of keywords. Just to you need to just know about them. Okay. Yeah. Now we have ports and data. The input ports. Okay. Let's take the two basic ports are like input and output. Now we have the input ports, which will be receiving the signal safely into the module from external sources, like an input from the sensor, which is connected to the processor. Okay, and you can see the output ports, like it will be passing the signal from the microcontroller to the actuator or any display device. Okay, you can simply know input is a thing. Input and ఏంటి the port which is carrying the input information from the sensor to the microcontroller, where output port is a thing which will be carrying the information from microcontroller to output, like the LCDs or motors or something. Okay. The main data types are here wire. Okay. You can see it is used for continuous connections and structural logic mapping. And wherever we use reg, okay, use it for procedural assignments inside always blocks. Okay, I think it is about the register. Okay, now we have the logic, which is SystemVerilog. It is modern and versatile type that intelligently replaces both wire and reg. Okay, you can simply replace both of them using this one. Okay, now you have continuous assign. Now you have the assign statement is used exclusively for combinational logic operations that do not require state memory. Okay, you need to know. Okay, this assign statement is used for only for the combinational logic operations. Okay, that does not require state memory. Like you people know the logic gates. Okay, the adders, full adders, mux, demux, etc., etc. And wherever if we gone through the sequential circuits like flip flop, okay, like these are the memory based elements, right? So assign statement is used for those elements which don't require any kind of memory. Okay, so you can see assign y is equal to a and b. Okay, it will compare, then it will perform the operation. Now we have the applications of the assign statement. Okay, as it is known as continuous assignment, or it is also used for the combinational logic operations. It is used in basic logic gates like and, or, not, etc., etc. And I already said that we can use it in the multiplexers and data routing. And also, you people know the arithmetic operations like arithmetic and addition and subtraction will be performed by the adders, full adders, subtractors, and whatever it is. Okay. So in this, okay, these are all the combination circuits, right? They don't need any kind of memory. It completely depend on the present inputs itself. So it is best for the arithmetic operations like addition and subtraction. Okay, you need to learn all these concepts as soon as possible so that you can understand the upcoming topic. Now we have the procedure block, and the keyword which we use is always. Okay, procedural blocks are used to describe behavioral based hardware. Okay, these kind of blocks execute sequentially within the block but runs in parallel with other blocks. Okay, it is like going as a group. Okay, and also they are in the same path, like they can be in the same speed because these run on parallel. Okay, mainly the key mechanisms include in this are the sensitivity list. Okay, it always triggers the block execution. You need to know this. And the blocking assignments are is equal to symbol. Okay, it executes sequentially, and non-blocking, which is the less than symbol followed by an equal symbol, which shows that it's executing concurrently. And now we have implementation types. Okay, combinational always block. Okay, which is only evaluated immediately upon input change. You people already know combinational elements doesn't have any kind of memory, so the output will be evaluated immediately upon input changes. Like if the input goes from 0 to 1, Okay, the evaluation will be done. Now here we have the sequential always block. Okay, evaluates trigger by a clock edge. Okay, you can see the some of the logic here, like some of the simple programs written here. You just refer it through it. Then now we have how to design a combinational circuit. Okay, to design a combinational circuit, you need to know its characteristics, right? So in designing of a combinational circuit, you need to represent the digital logic where the output is purely a function of the present input. We already have been repeating multiple times that there will be no memory elements in combinational circuit, and if there is no like such components, we don't need any clock. Okay, and also I have been repeating that output depends only on the current input. Okay, and yeah, now some of the mini designs which you can perform is logic gates. You can do it. Okay, the multiplexers, decoders and encoders. Okay, adders and some of the magnitude comparables like that. Now we have the designing of sequential circuits. Okay, as we know, the major change in the sequential circuits are it will have a memory which will be also like affected by the passed out. Now we can see that sequential circuits differ from combinational by utilizing memory elements, as we already said. Okay, and these are allowed them to store state based on clock signals. Okay, these clock signals manipulate everything. Now the key concepts in this are using a centralized clock signal for all the circuits. And now we have the memory, so it can store memory and in the internal state. Okay. Now you have some edges in this, like rising edges, falling edges, and triggering. And you can also know about synchronous and versus asynchronous reset logic. Okay. Now we have the design topics which are involved in this, like D flip flops, latches, shift registers, synchronous counters, FSMs, etc. etc. Okay. Now let's see about the verification test benches which are used in VHDL programming. Okay. A test bench. Okay, it's not a bench like I have something to keep on this phone or some laptops. Okay, it's not like that. Actually, the verification test benches are a test bench is an isolated circuit code that instantiates your design. Okay, simulates it with inputs and verify whether the hardware works correctly. It is just a testing unit where it will be simulating the circuit. Okay, and verifies that whether the hardware is working properly or not. Okay, it applies control input vectors, observes and log all the outputs and detect, and also it will be reporting the logical error. Okay, this is a small snippet out of it. Now you can know what are the simulation tools which are used in this are Model Sim or Questa. Okay, it is a professional HDL simulator heavily used in semiconductor industry for robust verification. Now we have the Icarus Verilog and GTK Wave. Okay, you can have a screenshot if you want. Just learn all these tools if you can access them for free. Okay, now we can see some of the practical project ideas. One is the 4-bit adders. Okay, you can see some of the projects here. I will simply, you can have a screenshot of it. Okay, I have, I will pause for a few seconds. Okay, okay. By performing these projects, you can add some way to your resume. Like you need a good job. Okay, you need to do. a good project, not like a old-fashioned IoT project or any kind of audio kind of thing. Okay, you need to design a chip rather than using the chip. Okay, now let's go on to the next one. Now we have the arithmetic logic unit, okay, which needs, okay, which is the, okay, the ALU is a central computational core of the microprocessor which will be performing all the addition and the logical operations. Okay, now we need the blocks like addition and subtraction. Now we have the logical and or not and bitwise OR operations and shift operations like logical or arithmetic. Okay, you need to learn the ALU modeling. Okay, you need to learn the multi-operation logic routing and whatever the control signals are there. Okay, to do this project. If you did this, like you will go ahead because like you need, rather than designing a small circuit, you are combining a large number of blocks. Okay, so you will be making your own ALU. Now we have a traffic light controller. Okay, you can make it using the FSM based design, or else you can do using any other kind of topics in which are involved in the VLSI. Okay, now you can implement this control logic utilizing SM's architecture, like for the FSM and more versus melee machine logic. And now you have to use the hardware timers and counters, and also you need to use advanced sequential logic integration so that the size of the chip will be less, or else it will be very huge. Now you need to learn the UART programming or UART protocol. Okay, like it is like connecting the both TXRX into the, okay, if it is as a TXRX and it has a TXRX, this TX will be connected to this RX will be connecting to the this TX, like that you will be knowing. And the main applications of the UART comes under the embedded systems, microcontrollers, FPGA, etc., etc. Okay, and these are the some of them. Okay, if you want, just comment us or you can simply contact us. We will share the PPT so that you can use. Okay, I think with this session we have covered some of the Verilog fundamentals, but not all. Okay, the sequential combinational logic and industry standard tools, some of them, and some of the real world project ideas. Okay, stay tuned for more project ideas and some of the. We are also going to launch some modules also. You can check it out later. And thank you for joining. Let's meet in the next session. Thank you, all of you.